Hi everyone, welcome to Recitation 5. Today I'm going to solve two problems from assignment 3. So first I'm going to start with problem 4.16. So it says that to show that the peak response from problem 4.15 is equal to this expression. So let's see the equation for the peak response. So for 4.15, the the equation is given as omega n. It would be there is a printing mistake here. It would be omega n multiplied by z over v naught is equals to 1 over omega n t1 multiplied by 1 minus ft1 mv naught 1 minus cos omega n t minus sine omega n t, where k is the stiffness of the spring, m is the mass, F is the constant friction force from the Coulomb damper, and T1 is the time when V is equal to 0. Now, let's start it. So first we will just start with the given equation, which is this omega nz over v naught is equals to this, as given in problem 4.15. So we know that when z is equal to z max, or the peak response, then the dz over dt is equals to 0. So we're just going to differentiate this equation. So I'm going to write omega n over v naught dz over dt is equal to 0. So let's differentiate it. So here 1 over omega n t1, 1 minus ft1 mv naught, these are constant. A differentiating 1 will give us 0, and minus cos omega n t will be omega n sine omega n t1, and sine omega n t would be omega n cos omega n t. Now here this omega n gets cancelled, so we can write 1 over t1 multiplied by 1 minus ft1 over mv naught sine omega n t1, and I'm just going to take this term the other side, so we have equals to omega n cos omega n t. So now I'm going to write sine omega n t1 over cos omega n t1, which means I'm going to this t here. Here we have omega n t1, and this here, which is 1 minus ft1 over mv naught. So we can write tan omega n t1 is equal to omega n t1 over 1 minus ft1 over mv naught. Now, if we have a right angle triangle where this side is omega n t1 and this side is 1 minus ft1 mv naught, then we can say this side would be root over omega n t1 square plus 1 minus ft over mv naught whole square. From that, we can write that sine omega n t1 is equals to omega n t1 over root over omega n t1 square plus 1 minus ft1 over mv naught whole square, and cos omega n t1 is equals to 1 minus ft1 mv naught over omega n t1 square plus 1 minus ft1 over mv naught square. So we have calculated the expression for sine omega n t1 and cos omega n t1 because it was in our original equation. So I'm just going to put this value over there for the peak response. So as we mentioned, in the peak response, z is going to z max. I'm just putting the value of cos omega n t. which is this equation, and it's plugged in here, and the expression for sine omega n t, this one, and it's plugged in here. Now we have almost got this equation, just we need to simplify it to get it in this form. For that, what I'm going to do is I'm going to multiply the denominator and numerator of this fraction with 1 over omega n t1. So if I multiplied it for 1 over omega n t1, and I will get here 1 over omega n t1 multiplied by 1 minus ft1 mv naught, and for here it will be this whole term will be would be like divided by omega n t1. So if I take it inside the square root, then it would be omega n t1 square divided by omega n t1 square, which gives us 1, and here it would be 1 over omega n t1 multiplied by 1 minus ft1 mv naught. Similarly, we're going to do the same for this equation. So if I multiply it by here 1 over omega n t1, this one get cancelled, and for here it will give us the same equation. So the omega n t1 square will become 1, and there comes a 1 over omega n t1 multiplied by 1 minus ft1 mv naught. So from that we get the form given in problem 4.16, and our equation is proved. Here it is. Okay, so next I'm going to solve another homework problem, which is 4.21. So in problem 4.21, it's given that for a triangular pulse of duration t1, show that when t1 over tau is equals to half, the peak response occurs at t equal to t1, which can be established from the equation 2 cos 2 pi t1 over tau over tp over t1 minus 0.5 minus cos 2 pi t1 over tau tp over t1 minus 1 minus cos 2 pi t1 over tau multiplied by tp by t1 is equals to 0. So for that, we're going to start from the equation of displacement of a triangular pulse of duration t when t is greater than t1. So you can find this equation from here, problem 4.12, when t is greater than t1. So I just wrote the equation here, which is x equals to 2f naught over k multiplied by tau 2 pi t1 minus 2 sine 2 pi t minus half t1 minus sine 2 pi over tau t minus t1 minus sine 2 pi t over tau. Now in the second line, from here I'm going to take the t1 out. So I have got the t1 out. So this expression becomes t over t1, and this has become just minus 0.5. Similarly, also from here, I'm going to take the t1 out. So it will become 2 pi t1 tau, and this expression will become t over t1 minus 1, and this will remain the same. Now, since we are going to compare our equation for the peak response, we know that when x is equal to x max, the dx is dx over dt is going to be 0. So next we are going to find the expression for dx by dt by differentiating the equation of x. So here dx by dt is equal to 2f naught k tau 2 pi t1 minus, we can write for this expression first, it's going to be chain rule, so cos 2 pi t1 over tau t minus t1 minus 0.5 multiplied by, now if we are going to divide it, we're going to multiply with this, so that will be 2 pi t1 over tau into 1 over t1 since we're applying the chain rule. Similarly for here, it would be cos 2 pi t1 over tau t by t1 minus 1 multiplied by 2 pi t1 over tau multiplied by 1 over t1 minus, and for this it would be cos 2 pi t cos 2 pi t over tau, and it will be multiplied by 2 pi over tau. Okay, so now for dx by dt we have got 2f naught k. Since we have 2, now we are going to cancel out this term, so the tau 2 pi t1, it cancels out this one and we get the t1 out. It also cancels out this one and we got the t1 out. Here we only have 2 pi over tau, so we are going to multiply with t1 over t. So now for the, we know that for the peak response x equals to x max, the dx by dt is equal to 0. So I'm just going to set this whole equation for 0, and from that I can write that 2 cos 2 pi t1 over tau multiplied by t by t1 minus 0.5 minus 2 pi t1 over tau t over t1 minus 1 minus cos 2 pi t over tau t1 into t is equals to 0. Now if I compare this expression with the given equation, which you can see here from the problem, you'll find that in this equation the forms are exactly similar, and here the only difference is for t is equals to tp here in the given equation, and this t is equals to is tp, and this t, or is, sorry, this would be t1, so this t would be equal to tp. So comparing this equation with the given equation, we can say that t1 is equals to tp. So that's all I had for today. Thank you for attending. Bye.